Assalamualaikum and hello everyone. My name is Azafika bin Khairuddin with the matrix number of AA211877. As for this time of the basic electric and electronic assignment, me and my group member will be presenting to you about transformer. Alright, before we going further down the slide, I will introduce to you my group members that will be working with me throughout the video presentation. First off, we have Edi Amirul Aiman bin Edi Miss Mulyadi with the matrix number of AA210012. Next off, we have Nur Fitriana Fatin bin Jamrin with the matrix number of AA211335. Next is myself. And next, we have Nur Ain Natasha binti Muhammad Zaid with the matrix number of AA210970. And last, we have Muhammad Iqbal Dania bin Jamaluddin with the matrix number of AA211291. Alright, for this part of the slide, I am going to tell you the objective of our group presentation. Alright, from learning the transformer application, student will, first of all, aware of the transformer application. Secondly, know that transformer can set up or step down the voltage level from the AC source. Alright, and lastly, learn about the function of transformer, including the transformer circuit, as well as its application in real world. Alright, continue on with the next slide. I am going to talk about what's today's discussion. We are learning an introduction to transformer, which a transformer is a device used in electrical systems to connect a circuit that operate at various voltages. These are frequently employed in applications where AC voltage conversion from one voltage level to another is required. The usage of a transformer in an AC circuit can either lower or raise voltage and current depending on the need of the electrical equipment, device, or load. Transformers are used in a range of applications, including power, instrumentation, and pulse transformations. Alright, now I'm going to pass on to my group member for the next slide.
Thank you to Azafika. Next, I will explain more about the relationship between inductance and transformer. In terms of appearance and manufacture, transformers and inductors appear to be extremely similar. They do, however, serve diverse purpose and have distinct design and construction characteristics. So now let's see the differentiation between the inductance and transformer. First is inductor. An inductor, also known as a choke or reactor, is a two-terminal electrical component that is passive. It is constructed from an electrical conductor, such as a wire twist in a coil. A current passing through it will momentarily store energy in the coil's magnetic field. The second thing is transformer. A basic transformer is made out of two coils of insulated wire. The wires in most transformers are twisted around an iron-containing structure known as the core. One coil, which is the primary, is connected to an alternating current input source, and the other coil is generating an alternating current as a result of the magnetic field. We can see the relationship between inductors and transformer in the working principle of a transformer. Faraday's law of electromagnetic induction and mutual induction govern the operation of the transformer. On the transformer core, there are two normally coils, which is first is a main coil and second is a secondary coil. Strips are used to connect the core limitations. The mutual inductance of the two coils is very high and changing magnetic flux is occurred when an alternating current flows through the primary coil. This shift in magnetic flux induces an EMF, which is electromotive force, in the secondary coil, which is connected to the primary coil, according to Faraday's law of electromagnetic inductance. That's all from me. Next, I will pass to Eddie to continue our presentation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Edi Amirul Iman bin Edi Miss Mulyadi. Now I will be explain about the voltage ratio, current ratio, and transformer efficiency. First, I will be explain about the voltage ratio. The voltage ratio is of primary voltage to secondary voltage is known as the voltage ratio. As mentioned previously, the ratio of primary turn off wire to secondary turn off wire is known the turn ratio. By substituting into the above equation, we can find that the voltage ratio is equal to the turn ratio. So we can use this formula, that is voltage primary over voltage secondary equal to number of term of wire in the primary over the number of term of wire in secondary to find the voltage ratio. So when the transformer efficiency is 100%, the power at the primary equal to the power at the secondary. Power rating refer to secondary within the real transformer. Next, for the current ratio is the inverse of the voltage ratio. The secondary does not generate power but takes it from the primary. The current step up and step down is term of the secondary current, which is determined by the load resistance across the secondary voltage. Since the transformer transfer electrical power from one circuit to another circuit, vary efficiency with the negligible power loss. So when we want to find the current ratio, we should use this equation, that is the output power equal to input power, where IS over IP equal to VS over VP. So when we use this formula, we can find the current ratio for the circuit. Next, for the transformer efficiency, the ratio of transformer output power to input power is known as transformer efficiency. The effect of transformer loss is measured by the transformer efficiency, which is typically expressed as the percentage. So the formula to find the transformer efficiency is power output over power input times 100%. Assuming the zero loss in the transformer, power out equal power in, and the efficiency is 100%. Last, actual power transformer have an efficiency of the approximately 18 to 19%. Next, I will be explain about the transformer rating. Transformer are designed based on the voltage and current necessary to operate the transformer. Then they then specify in the term of the voltage and voltage current on the transformer nameplate volt and ampere. This is referred to the as transformer rating. The rating of transformer can also refer to maximum voltage and the current that can be safely applied to it. A transformer rating is determined by temperature rise, which is determined by the transformer loss using the correct cooling system. However, the temperature can be kept below an acceptable level. Higher the rating of the transformer, the more effective the cooling system is, the vice versa. The rating of an electrical machine is indirectly determined by the loss existing in the machine for the certain cooling system. So there are two types of the loss in the transformer. First, the constant loss, often known as the core loss, are determined by voltage. Second, variable loss, often known as the ohmic loss, those that dependent on current. As a result, total loss are determined by voltage and current. Because transformer rating is determined by the loss and loss are determined by voltage and current, transformer rating is determined by the voltage current. sometimes known as a voltage current rating, because loose independent of load power factor. The transformer rating is also independent of the load and can only be determined based on the loss. That's all for me. Thank you.
I will continue our presentation by explaining about calculation of transformer. So as you see the diagram below, this is the example of transformer. Transformer equation can be written as Vp over Vs equal to Np over Vs, or you also can use Vp times Ip equal to Vp times Is. For your information, Vp is primary voltage, while Vs is secondary voltage. Np is number of turn in the primary coil, Ns is number of turn in the secondary coil, and Ip is input current in primary coil. For question 1, he already give us Np, Ns, and Vs. So he asked us to find Vp. So by using transformer formula, which is Vp equal to Np over Ns times Vs, we got 232.5 volts. Next is question 2. He asked us to determine the amount of secondary voltage. In the questions below, we already know that Np equals to 110, Ns equal to 240, and Vp equals to 300 volt. By substitute it into the formula, we got 654.55 volts of secondary voltage. And move to the last question is different because he gave us Vs equal to 15, Vp equals to 220, and output power equals to 80 watt, and efficiency equal to 65%. So firstly, we need to know the efficiency formula, which is output power over input power. So by rearrange the formula like the diagram shows, we got the amount of current in the primary coil, which is 0.56 ampere. So that's all from me for the calculation of transformer. Thank you.
Thank you to Iqbal Daniel. Now I present about application of transformer in real life. Does transformer have its application in real world, such as regulating alternating current? The main function of all transformers is to increase or decrease alternating current in the electrical system. The transformers enables for better energy efficiency by regulating current flow, which regulates and ultimately lowers electricity expenditure. The second one is stopping and starting the flow of electricity. Transformer can also be used to interrupt an electric current or stop the flow of electricity. Transformers are frequently found in circuit breakers, where they use a switch to automatically block the flow of electricity and protect against high voltage damage. Next, battery charging. The operation of generators fulfills the concept of battery charging. Transformers are used to regulate the voltage that enter the battery during the charging process, preventing harm to the internal component of the battery. This is critical since an unregulated voltage might generate significant triggers during battery charging. The fourth application is steel manufacturing. High voltage transformers are used in steel manufacturing plants to provide a range of voltage for the manufacturing process. During the melting and welding of steel, high current are necessary, but during the cooling process, lower current are required. Transformers are required to supply this variety of voltage by regulating currents inside the system. Last but not least, electrochemicals. Electrolysis is generally full by the operation of transformer in chemical engineering and manufacturing operations. Electroplating typically involve the use of metals such as copper, zinc, and aluminum. Transformers are utilized to create a regulated electrical current that is employed to drive the chemical reaction from the start to the finish. As a result, the current can be controlled as the reaction progresses. That's all that related to this part. Next, I will present about conclusion. As we know that a transformer is a device used to change AC voltage magnitudes of any value taken from a sources to any desired value for the purpose of distribution and consumption in an electrical AC power distribution system. The constant voltage current magnitude rating of a transformer, whether on the primary or secondary side, it is most important property. By selecting a proper transformer ratio and keeping VA constant, it is possible to achieve a greater voltage with lower current or a lower voltage with higher current. The capacity of such a device to take in high current produced at low voltage from electrical generators and turns this power at a higher voltage level with reduced current is main advantage. This ensures that power on the order of several megavolt amperes is transmitted over a long distance at low current magnitudes in a cable of practical proportion. Today's transmission and distribution networks rely largely on this technology, and transformers are widely utilized around the globe. That's all from us. Thank you.